So I'm going to be talking today about developing block games with Unity. So my name's Tom Clifton. I work for a company called Stick Sports based down in Sydney. So the aim today is to give you a bit of an overview about what blockchain is and how it can be useful with games. And then subsequently, we're going to go into a few details about how you can get started integrating blockchain with Unity as well. So first off, we're going to go through and have a little primer on what blockchain is for anyone who doesn't know. We're going to talk specifically about the Etherium blockchain as well, which a lot of people are using for developing apps. We're going to have a case study on Kitties, which is probably one of the most popular games using blockchain to date. We're going to talk then about why do we want to have blockchain in games, what benefits it can give us. We're going to briefly talk about Stick Cricket Super League, which is a project we're working on at Stick Sports. And then finally, we're going to talk about actually integrating Ethereum or the Ethereum blockchain with Unity, and then with some Q&A. Okay, so firstly, what is blockchain? Best place to start is by looking at Bitcoin. Bitcoin's probably the blockchain that most people are most familiar with. It's certainly the one that brought blockchain technology into the kind of popular conscience. So it came around the financial crisis, around 2008, 2009. And Bitcoin isn't actually a blockchain itself, but is built on top of a blockchain. So it's actually a cryptocurrency that's built on top of a blockchain. So with Bitcoin, the big difference there compared to other currencies is that there's no central authority, there's no clearinghouse or central bank that sort of authorizes payments. It's a peer-to-peer network where it's up to all the nodes in the network to kind of authorize and validate payments. And to do this, it makes use of a distributed ledger. So I'm going to talk about ledger in a second. Here. So a ledger is a term that's used a lot in banking. So you can think of it a bit like your bank account where you've got a series of transactions one after the other. So it's a record of a number of transactions. So in your traditional model, where you'd have a centralized ledger, where you'd have a clearinghouse or a central bank that sort of owns that ledger, and they are the trusted party that you're trusting to keep an accurate record of all the different transactions that have gone on, and everyone has to deal with that central authority. So one of the downsides of this is it can be incredibly slow. You also have to have a lot of trust in that central authority to not only be trustworthy, but also to make sure that everything's secure. With a distributed ledger, everyone actually has, every node in that network has a copy of that ledger, and it's up to the whole network to validate that that ledger is correct and sort of represents the ultimate truth of all the transactions that have gone on. So blockchain is exactly what it says on the tin. It's a chain of blocks. So each block is basically just a container full of some amount of data, which is basically a number of transactions that have been packaged together into this block. Each block in the chain has a hash, which is a unique fingerprint for that block, and is also dependent on that data. So if you change the data, you change the hash and that unique fingerprint of it. Additionally, you also have a hash that points to the previous block in the chain, which is how the chain is built up. So you can kind of, for any programmers, you can kind of think of this as being a little bit like a linked list as a data structure, really. So what that does is it makes it incredibly difficult to actually change data that is stored on the blockchain. Because if you've got data there and you want to change the data, say, for that first block, that's then going to change the hash for that block, and then you then have to change all subsequent ones pointing to that block, which can be quite computation expensive, particularly the longer and longer that chain gets. There are also a number of other mechanisms that make it even harder to to change and to hack a block. So blockchain, as I said, is a peer-to-peer network really, or a node-to-node network. So one of the ways that Bitcoin, or the way that Bitcoin, one of the ways that Bitcoin makes this harder to hack is to actually make the process of creating a block quite difficult and quite time-consuming. So the current rate is about one block gets created every 10 minutes on the blockchain. So if you wanted to hack a blockchain, you'd have to change the contents, sort of reapply or recalculate blocks for all the subsequent ones, and you have to sort of actually mine, we call this mining, the block, which takes about 10 minutes at a time. And it's only the first person who mines a block who gets to create it. So the mining is, there's a series of nodes that are trying to mine the block, which is basically just a cryptographic puzzle. So everyone's taking part in this, and they're all trying to mine this block. And it's the first person who gets the answer to this puzzle that actually gets to create that block and apply it to the chain. So the algorithm that does this is designed to be basically chance. So you need a lot of computational power and you need a lot of luck. And it takes about 10 minutes on average to create a block. So yeah, if you wanted to hack the chain, you'd have to be the first to create the block every single time. And the way the algorithm works is that even though it's incredibly computationally expensive to find the answer to this puzzle and to actually create that block, once you have it, it's actually very easy and very trivial for other nodes on the network to validate it. So once you've got the block and you've added it to your chain, you then broadcast that to the network, and then the network confirms that that is a valid block and that they can add it to the chain. So that means that if you were to try and hack the network, as well as doing everything I've mentioned, you also have to take over 50% of the nodes in the network. So the larger and the more distributed that network is, the harder and harder that becomes to do. So something like Bitcoin, which is quite heavily distributed, is almost impossible in practice to hack and to actually change the records on the chain. So some of the advantages of blockchain then are trust. So you can trust that the data that is on the blockchain is what it says it is, that it hasn't been hacked, that it hasn't been modified, because everyone on the network is constantly validating all of this. It's open, so every node on the network has a copy of the ledger. They've got a copy of every single transaction that's ever been made, which means it's incredibly open and transparent, as opposed to something, a more centralized system where you're trusting some authority with that information, but you don't really know what that information is. And it's distributed, which makes it quite secure, as I've mentioned, because there's more people involved in validating it, and again, the more distributed it is, the more secure it is. So then moving on to Ethereum. Ethereum is probably one of the most popular blockchains to date, certainly with developers. And this is due to a concept that they've brought in called distributed apps, or DApps, or dApps. So these are enabled by the fact that there's a programming language built into Ethereum. So one of the key differentiators with Bitcoin, for example, is you can kind of think of Bitcoin as being a bit like an early digital calculator. It does only a few things, and it does them very well. You know, if you want to multiply or add or whatever, it does those things very well. But if you want to do anything more than that, it's pretty much useless. It's very, very hard to do anything other than that. Whereas Ethereum is a bit more like a general purpose computer, in that because it's got a built-in programming language, it actually enables you to do all manner of things that the developers of Ethereum probably wouldn't even have imagined. It's being used in all sorts of weird and quirky ways, and people are constantly coming up with new use cases for it because you can program it. Okay, so to do this, one of the core concepts with Ethereum, as opposed to Bitcoin, is something they call smart contracts. So smart contracts are essentially just small computer programs that are stored on the blockchain. With Ethereum, you have two types of accounts, as opposed to Bitcoin that only has one account, which is just a user account where you where you send and receive money from one account to another. So Ethereum also has this sort of account. It's called a user account. And these are managed by private keys. So it uses public-private key cryptography, which, for those who don't know, it's a commonly used method where you've got two keys, both of which can encrypt a message, but only one, but you need the other one to then decrypt that message, which gives you encryption and what's the other one? Encryption and sort of proof of identity. So yes, Ethereum uses these public-private keys. So you have a private key that actually signs transactions and a public key which is associated to your address on Ethereum, where you can actually sort of receive sort of whether money or transactions or messages or whatever it is. And with Ethereum and Bitcoin as well and other blockchains, you have this idea of digital wallets. So wallets aren't actually a container for money. They're not like a bank account. They're really just a collection of your digital credentials, your private and your public keys, and so forth. And they just make it easier for you to sign transactions and interact with the blockchain. So yeah, they help with that. And you've got different types of wallets as well. You've got sort of web-based wallets or apps, or you even have dedicated hardware wallets for this sort of stuff. But it doesn't actually store any money. So the other account then is the smart contract account, and that one's new with Ethereum. So the idea with this is, as opposed to being controlled by someone's private key, it's actually controlled by code, which is the program itself. So as I said, yeah, they're small programs that are stored on the blockchain themselves, and they have a public address just like a user account, so you interact with them by interacting with that address. They're immutable, which is to say that they can't be changed. And again, this is due to the nature of blockchain, where once something's on the chain, it's on there. You can't get rid of it or change it. So that does bring up challenges in terms of upgradability. So you have to think very carefully about how you want to upgrade your contracts if you do, and or what that process would involve. So you can't change the contract itself. So upgrade processes normally involve pointing users to your new address for your contract, but anyone can still call the old contract. They're distributed, which means that they're on the blockchain, so any node in the network can call any of these contracts. They're not sort of private or anything, but that does open up a lot of sort of power and flexibility, particularly as contracts can call other contracts as well. So it uses a programming language, or there's a few programming languages you can use, but the most popular is one called Solidity, which is a JavaScript-like language, or it looks very similar to JavaScript anyway, but it has a number of core concepts to blockchain actually programmed into it, which I'll talk a bit more about in a second. And this programming language compiles down into a bytecode that is run on something called the Ethereum virtual machine, or the EVM. And you can think of this as being like a huge distributed computer. But essentially, yeah, it's just the part of Ethereum that actually runs the code. And this runs on all the different nodes in the network, or whichever nodes are processing your transactions anyway. So one important concept that I haven't mentioned that Ethereum also introduces is something called gas. So gas is quite closely related to Ether, which is Ethereum's kind of currency, if you like. One analogy for Ether is that it's like digital oil, that it's the fuel that makes the whole network run. And gas is kind of like an extension of this analogy. So gas is basically just a fee that you pay whenever you make any sort of transaction. So if you call a contract, or if you want to send Ether or money to someone else, you have to pay an amount of gas. And the reason for that is because these programs aren't running on your computer or your users' computers. They're just running on random nodes in the network, and it's a way of compensating the people running those nodes for actually doing the computations. So it's charged on a per computation step, which means that smart contracts tend to be small to try and avoid as much unnecessary computation as possible. And they also have a gas limit. So you specify how much you want to pay per computational unit, and you specify a total amount that you're willing to pay. And one of these things one of the things that it does introduce, or one of the things it's designed for, is to encourage responsible development. So if you've got a dodgy program that's making infinite loops or taking longer than expected to run, it's going to hit that gas limit, and then it's going to sort of terminate, and all the state associated with it is going to get reversed, but you still have to pay the gas. So it encourages sort of well thought out and put together programs. Yes, and it incentivizes contracts with high gas prices being mined. So miners, when they create a block and apply it to the chain, as I mentioned, they bundle a load of transactions in it, but they get to choose which transactions they want to process. So if you specify a higher gas unit, it means that they're more likely to pick your transactions to process before others, because they want to get that reward, so the gas goes to them, as well as a reward for creating the block. So CryptoKitties is probably the most successful blockchain-based game to date. This was generating millions and millions of dollars at its peak, and it actually brought the whole Ethereum network to a crawl at one point because of the sheer number of transactions that were being made. So it's incredibly popular, or it was incredibly popular at its peak. And the whole idea of this is that you breed and collect these virtual cats, or kitties, crypto kitties, and then you trade them. So there's not a whole lot of gameplay there, to be honest. Really, it's a sort of an experimental product that the developers put out there just to sort of explore tradable assets. So it uses something called non-fungible tokens for each of these cats. Fungibility is the concept that any two tokens are worth the same amount. So a dollar, for example, is a fungible token in that any dollar is worth the same. My dollar is worth the same as anyone else's dollar. It just doesn't matter how sort of dented or whatever it is. Non-fungible tokens are different. Every single token is unique and has a unique value associated with it. And this actually provides a lot of benefits for particularly things like tradable assets or games, where you've got unique assets. That's what the developers for CryptoKitties were sort of exploring with this product. And it was mainly a kind of a sort of an experiment, but turned out to be this huge success. But if we look at how to play the game, I say play because there's not that much you can do with it, to be honest. You have to first buy some Ether, which involves going to an exchange, such as Coinbase, setting up an account, and paying with real money to get some virtual Ether. You then have to create an Ethereum account and a digital wallet. For CryptoKitties, MetaMask is one of the digital wallets they recommend, which is an extension to Chrome. So you've got to go and install an extension to Chrome and sign up with them. You've then got to transfer the Ether to your wallet. You've then got to actually create a CryptoKitties account as well. And then you get to play, which is basically paying money for a cat and then pressing one button to breed it. So there's not a lot of gameplay there. And to be honest, a lot of the blockchain games that are out there at the moment are pretty much this. They're there for crypto enthusiasts, and gameplay is like a completely secondary priority. So that's not what I'm going to be talking about. So, but it does point out a lot of constraints with the current sort of games on blockchains, which is there's a lot of faff involved in setting up wallets and setting up accounts, which is going to be hugely off-putting to any sort of users, particularly casual gamers, but even sort of hardcore gamers. There's gas costs involved as well. So I mentioned gas previously. It's actually the user or the player who actually has to pay the gas costs. So that is, most people don't want to be making microtransactions constantly. And the transactions are slow as well. So I mentioned Bitcoins, there's a block about every 10 minutes. Ethereum's a bit quicker. It's a block every 15 seconds or so. But if you compare that to something like Visa, popular payment system, they do about 2,000 to 5,000 transactions every second. So it's considerably slower. So these are some of the challenges at the moment with blockchain development, which kind of begs the question of, why do we want to bother? Like what are we getting for all of this and having to deal with these problems? Well, we think, and there's a lot of people that increasingly think there's a lot of opportunities with blockchain for games, particularly around the tokens and tradable assets side of things. The biggest one is player ownership. So with blockchain, players truly, genuinely own their assets. So it's not the developer who owns it. I can't take, if a player in a game has bought an asset or has earned an asset in game and it's in their Ethereum wallet, they own it. As a developer, I can't take it away. No sort of other authority can take it away, Microsoft or Google or the government or anything like that. It's theirs to own, and there's nothing I can do to change that. You also have unique tradable assets. So a lot of games have tradable assets, but these are truly unique tradable assets, and it enables sort of natively players to go and trade these assets. They can trade it outside of your ecosystem as well. It doesn't have to be in your game. These smart contracts are available for every node in the network, so anyone can do this. There's also a lot of interoperability as well. So if you wanted to have assets that you wanted to use across multiple games, or like a soft currency that you wanted to use across multiple games, you could implement that as tokens. And another advantage of this as well, which Kitties is a good example of this, is that because you've got these sort of open smart contracts that anyone can access, you get this sort of community of third-party apps and games that crop up. So there's a number of third-party apps that make use of CryptoKitties because it's all open and distributed. And it's actually really good for the community because it's just more people getting involved in CryptoKitties, and ultimately the developers are then getting more people into the game. So Stick Cricket Super League. So Super League is a popular product. It's one of our best performing product at Stick Sports, and we're soon going to be introducing blockchain elements into that game. So that's going to be in the form of bats, which will be tokenized assets. So again, unique assets that you can buy and trade and sell, and that players truly own, and they will make a difference to them in the game. So moving on to Ethereum and Unity, there are a number of, it's still very new technology, but there are a number of ways of going about integrating this at the moment. So I'm going to talk about a few of the most promising of those today. The first is something called an Etherium, which is a .NET integration for Ethereum. So this requires the latest Unity 2018 series of products, or also Unity 2017, because it uses the .NET 4.5 version of the API, and so that's available in all versions of 2018. I think it's experimental in 2017 as well. So Ethereum supports multiple platforms, so mobile, iOS, Android, Windows PC as well. And there's a C# API that very closely matches Ethereum's API. So it's kind of quite low level. It's kind of a, sort of like a native integration of Ethereum, if you like, which does mean that you have to sort of deal with some of that native side of things. So, but that being said, the code's pretty simple. You kind of you have a contract address. You get a contract from it. You call a method on it. It gives you a sort of an object back, and you then sort of deal with that data. So these are just sort of samples from their docs. Another one is Loom. So Loom's getting increasingly popular. They're in public beta, or they're just ending a public beta. I'm not quite sure exactly where they are with it, but they're basically a service, and they've written an SDK that works on a number of platforms, but they also have a Unity SDK, again for mobile and for PC. So they're actually addressing some of the shortcomings with blockchain development, as well as abstracting some of the layers away from you, so you don't have to deal with so much of the sort of nitty-gritty details with blockchain. But one of the ideas that they're bringing up is this idea of a dApp chain. which is also often called a side chain. So the idea behind this is that you have another blockchain that's actually separate from the main blockchain, so it's kind of like a fork off the main chain. And then all your transactions occur on that side chain. And periodically, you sync up with the main chain, so things are still backed up on the main chain. So they treat the main blockchain as a sort of a secure base layer, and the side chain is kind of like a way of having a higher layer, which is a lot quicker to deal with. And plus, you get to, as this is sort of a secondary layer that's off the main chain, you can actually introduce your own rules. Because you have these chains that are specific to your app as well, you don't have to worry about things like proof of work so much and the mining aspects of it. So you can sort of reduce the gas cost and sort of process these transactions. You can sort of set up your own nodes, or Loom have a service where they'll set up some of these nodes for you for a fee. And you can sort of get much higher traffic through that, and then it backs it up to the main chain so that it's still, it's still Ethereum, it's still on the main network, and players still own their assets, but it's sort of an abstraction and sort of a high level. And again, the code for that's fairly trivial in terms of sort of getting a contract and then calling it again, so just from the docs. So the setup's pretty easy for this. The other thing is they've got a number of products out at the moment, and they're actually working on a blockchain game themselves. But they have a series of tutorials called Crypto Zombies that, if anyone wants to get into smart contracts development, is definitely the place to go. They're pretty fun and really informative, actually. And the last solution, which is possibly one of the more realistic ones at the moment, is actually having just a custom server. So this approach is where basically you just have a server which backs up all the transactions to the main network, and then players just create an account with your server in the sort of traditional model using a traditional web-based API, which does have the disadvantages that it isn't transparent and players don't really own the assets until it's on the main chain, but it does remove a lot of the hurdles that I've mentioned with blockchain development. So it's quick, you don't have to pay gas or deal with transactions or anything like that. So it's kind of a trade-off. And the trade-off can kind of be seen with this triangle. So all apps on the blockchain are sort of tending to pick a couple of sides of this triangle, and the more you move in one direction, the more you move away from the other. So the sort of truest blockchain apps, I guess, tend to be the ones that are most fully distributed and consistent. So they have consistent data, i.e. up-to-date data. So they're syncing regularly. But so something like Ethereum would fit on the bottom of that triangle, but the problem with that is that it doesn't scale very well, it's slow, you have to deal with transactions and whatever, so you're constantly making a trade-off between how distributed you want to be and how open compared to how sort of consistent and how much scale you want. And that is going to depend on sort of what your players would want and what's best for your users. So final thoughts. Blockchain development is still really new, really. It still hasn't really hit the mainstream, but it's getting there. Blockchain development tends to be thought of as being a little bit like sort of Web 1.0 in that it is so new, and you've kind of got these sort of basic layers in place, but that you really need sort of the higher level layers before it's going to hit the mainstream, and those layers are starting to get developed. They're things like dApp chains, side chains. Ethereum itself is introducing some of these concepts natively as well, and it is getting there. It's getting to the point where it's not far off hitting the mainstream. So anyone who wants to get involved and be an early adopter, now is definitely the time to be doing it. And there are some real benefits, particularly for anyone who's interested with ownable assets. I mean, that's the biggest benefit. But yeah, that's me.